outside with the naked eye, you may start to see this reddish color covering the moon. It will really become apparent at totality. So that's in around about 15-20 minutes, when the entire moon's face is covered by the dark shadow. Then we will clearly see this tinted color. We have a little diagram in the bottom left of our screen there, which shows what is happening. This is also explaining why we have such a short totality tonight, lasting only about 14 minutes. The moon, in this diagram, this is taken from the Earth looking into space, and we can see the Earth's two shadows there. There is the dark inner shadow, the umbra, surrounded by that lighter shadow, the penumbra. And what's happening in tonight's eclipse is that the moon is actually moving from left to right. The moon has come through the penumbra, it started moving into the umbra, and it's now nearly completely inside that dark inner shadow. But it's only just passing through the whole of the umbra. It's actually just passing through the very top of the shadow, not through the very center of it. And that's why this is such a short totality tonight of really just about 14 minutes.
And that could also affect the color of it, right, Graham? So we've got something called the Danjon scale that can kind of explain a little bit about the different colors of the total lunar eclipse.
Right, so every total lunar eclipse gets this sort of coppery, reddish, browny color, but it's always slightly different. It depends how deep the moon goes into the Earth's umbra. So tonight it's only just passing through the top of the umbra. That can give it a different shade to when it goes right through the very center of that dark shadow. It's also affected by the Earth's atmosphere. Remember, this reddish light that we're looking at, it's been filtered and bent towards the moon by Earth's atmosphere. Depending on what the atmosphere is like, for example, things like volcanic eruptions famously change the color.
We just had a volcanic eruption.
Exactly. And these things, they throw up particles into the atmosphere, and this can cause a difference to the color of the moon that we see during totality. In 1921, a French astronomer, André-Louis Danjon, he came up with a system for classifying the colors of total lunar eclipses, and he came up with a scale that we can see on the left of our screen, that runs from a number 4 at the bottom for the lightest, brightest shade, through to the number 0 at the top, which is the darkest shade. Occasionally, during totality, the moon does almost disappear. It becomes so dark that it becomes almost invisible. Other times, the color is much lighter, and the eclipsed moon looks a lot brighter, and it's much more like number 4. We never know exactly what kind of color we're going to get in advance, although we are expecting tonight, because it's only just passing through the top of the umbra, we are expecting a fairly brightish, lightish totality.
And also it's got to do with, like, when we're watching it here on the screen and not up in the sky. It also depends on what kind of exposure we're working on, what kind of settings your camera's got. Is there a filter? Is there not a filter? Are you using a color telescope or not? So we can look at the scale and we can compare, but we can never really know exactly what color the moon is, can we, Graham?
That's right. And we should say that, the Danjon scale is designed to be used with the naked eye. So
Yeah.
the